What does the term model mean in mathematics and the sciences? A model is generally considered to be a simplistic representation of a more complex object or phenomenon. It makes studying the object or phenomenon easier. Models can be ideas, pictures, mathematical equations, physical objects, computer simulations, or just about anything else that can represent a defined part of reality. All models share certain elements. They are limited representations of reality. Models must be context-rich and focus on relevant variables being studied. Model solar systems are rarely to scale, but still provide information about orbits. They must be validated, which means they must be able to make predictions that resemble observable phenomenon. The logarithmic model of pH allows us to predict how acidic or basic a solution is when we know its concentration. They must be appropriate for the desired purpose. Rats process fats and cholesterol very differently from humans, which makes them a poor choice for modeling human lipid-related heart disease. Models should be revisable. They need to be flexible and easy to update as new information or ideas become available. Models can be divided into three broad categories: abstract, physical, and sampling. Abstract models focus more on concepts and may be based on mathematical foundations. For example, Newton's second law of motion, force equals mass times acceleration, is mathematical, but can be applied to a wide variety of objects or situations. It could describe a falling apple or a racing car. Physical models can be pictures, scale constructs, living organisms, or anything else that can represent the relevant aspects of the system being studied. An example would be a cell model in biology class. Sampling studies use a small portion of the population or system to make predictions on a larger scale. It is important to ensure that the sample is truly reflective of the greater system being studied. Models can be further categorized as verbal, such as analogies or metaphors, static visuals, such as maps or dichotomous keys, or dynamic, such as simulations or functioning prototypes. Models can help us explain complex systems. They serve as guides for making predictions, and they can stimulate new ideas. A model of the heart, for example, can help students understand how blood flows through this muscular pump. Sketching free body diagrams in physics can help students identify all of the relevant forces and make reasonable predictions. Constructing a dynamic model of an ecosystem to understand a keystone species may stimulate inquiry into climate change or the impact an upriver city may have on the environment. In summary, models help us explore the complex world around us by simplifying objects and phenomenon. There are many different models. They allow us to explain, predict, and expand our knowledge. Thanks for watching.
Created using Powtoon.